optimization problem hospital. This code bringing by implement a random module. This space class has an int method that initializes the state space with the given dimension, height and width, and the number of hospital, num hospital. Self.house and self.hospital are set that will store that location of house and hospital respectively. The add house method always adding a house to the set space by specify its location, row or column. The available space method returns a set of all the, the available space method returns a set of all cell in the state space that are not occupied by a house or hospital. It first creates a set of all possible cells using the nested list compression, then it remove the cells occupied by house and hospital from the candidate seat. Finally it's return the remind the available cells. The hill climbing method perform the hill climbing algorithm to find the solution the problems. It takes three optional parameter: maximum number of iteration to perform, image prefix from output image, and log, whether to print the initial state cost. It state by initials that it state by initialize the self.hospital set to an empty set. Then it's randomly select location for the hospital from the available space and add them self.hospital. If log is true, it print the initial state cost. If image prefix is provide the call output image method to save image respectively of the state. Will maximum is non or count maximum less than maximum non count or less than maximum. This is the loop condition. It check if the either than variable maximum is non or the count variable is less than maximum. This means the loop will continue as long as either maximum is not provided or the count is less than maximum. Count plus or equal 1. This line increment the value of count by 1 in each iteration of the loop. It keeps track of the number of iteration. Best neighbor. Best neighbor. This line initializes the empty list best neighbors. It will be used to store the best neighbor set of hospital. Best neighbor cost is equal to none. This line initializes the variable best neighbor cost is none. It will be used to store the best cost of associate with the neighbor set of hospital. For hospital in self.hospital, this line started a loop that iterated over the each hospital in the self.hospital collection. It seems that self.hospital constants the set of hospital. For replacement in the self.get neighbors hospital, this line started another loop that the iteration over each replacement in the neighbor obedient from the self.get neighbors hospital. It's a happened the self.get neighbors is a method that's returned the neighbors of the given hospital. Neighbor equal to self.hospitals.copy. This line create a copy of the self.hospital set and assign it to the variable neighbor. Neighbor.remove hospital. This line remove the current hospital from the neighbor set. Neighbor.add replacement. This line add the current replacement to the neighbor set. Cost equal to self.cost neighbor. This line calculated the cost associated with the neighbor set. It seems that self.cost is method that calculate the cost based on given set of hospital. If best neighbor cost is none or cost less than best neighbor cost, this line click best neighbor cost is none or cost is less than best neighbor cost. If true, it update best neighbor cost to the cost and the set best neighbor as the list of continues only the neighbor set. If a best neighbor cost is equal to cost, if true, it's happened the neighbor set that the best neighbor list. Best neighbor cost is compromised against the cost of current state. Self dot cost self hospital is greater than equal to the cost of current state. It means the current state has the lowest cost found so far, so self dot hospital current state is returned. Obviously, a higher value neighbor set found and it is Obviously, a higher value neighbor set is found and it is the randomly chosen from the best neighbor list and stored in self.hospital. If log is set true, it print the message inclusion the cost of new neighbor set. If image prefix is provide the generator and image base current state. Random registered who is the represent the hill climbing process multiple time. Maximum is the number of time repeat the hill climbing algorithm. Best hospital based cost initialize the set of none. The hill climbing algorithm expanded maximum time in this loop. Each time the hill climbing each time the hill climbing function is called to the find new state hospital and it's assured the cost. If best cost is none, is if best cost is none, it's the first iteration. Or if the current cost is lower than previous best cost, then current cost and state assigned as the new best cost state. If log is set true, it print the message including the cost of new state. If image prefix is provide the generator image base in the current state. Finally, it returns Finally, it returns the best state, best hospital found the during the iteration of the hill climbing algorithm. Get cost. Function takes a loss of hospital as input and calculates the sum of distance from the house and nearest hospital. It initializes the cost of variable to zero for each house in the self.house list, calculates the minimum distance to any hospital using the nested list composition. The minimum distance is calculated as the sum of the absolute difference in the x coordinator and y coordinator of the house and its hospital. The minimum distance is added to the cost variable. Finally, it function return the calculated cost. Gets neighbor. The gets neighbor function takes the row and column indices of cell as im- input and return the neighbor cells to that do not already contain house or hospital. It initializes that condition list with the coordination of the hospital neighbor cells. It's then initialize an empty neighbors list. It iteration thoughts is candidate cell R or C and check if the already occupied by hospital or house. If the cell is not occupied and it falls within the bounds of the grade 0 greater than less than or equal R greater less than self dot height and 0 is less than equal c less than self dot width if the added of neighbor first. Finally, the function return the list of variable neighbors. The output image function. The output image function generates an image representation of the house and hospital grade along with the calculated cost. If implement necessary library such as PIL from image multiplication. It defines the parameter for call size, call border, call size, call fielding. It creates a blank canvas with the dimension and proportion to the grid size in the cost display size. It offers image of a house and hospital and relies then the mass of cell size. It's loads up front for the display the cost text. It's create an image draw. Object the draw on image. It iteration thought is cells and the grade drawing it irritation throughout the each cells in the grid, drawing restraints and the pasting the house and hospital image where necessary. After the drawing, all the cells re- is add a rectangle at the bottom of the cost displays. Is draw cost text within the cost display rectangle using the guest cost function calculate the cost. Finally, it saves the visual image to the specified file name. Here a space object is created with a height of 10 units and width of 20 units and the 3 hospital. Num dot hospital equal to 3. This space object represent a prendi- predefined area where the house and hospital can be placed. For for s add house random generator s dot height random s dot width. The loop runs the 15 time and at the house the space object s at a random height and width within the specified limit specified limit. The dot rand range function use the generator the random coordinator of each house. Hospital equal to s dot hill dot climb image prefix hospital log equal to true. This line applied a local search of algorithm called the hill climbing to the determine the best placement for the hospital in this space. Object S. The hill climbing method takes the hospital argument image prefix and log. The image prefix argument sufficient the prefix of saving the visualization of the implemented placement step as the image. The long argument enable the logging of this search process.